In example 8, we're asked to solve each equation, state our answer in terms of common logarithms, and then use a calculator to find the approximate value to the nearest hundredth. The method I prefer to use with these type of problems where we have an exponent that's a variable, or a variable in the exponent position for each side, is just to take the logarithm of each side. Also, we're asked to state our answer in terms of common logarithms. So if we just take a log of each side, that's a common logarithm of each side, and that'll work out well for us. What we can do now is we can take these exponents, put them out in front. That's our power rule with logarithms. You want to be sure to use parentheses if you have more than one term up here in the exponent. Now we can use the distributive property. Remember to think of log 5 as just being a number. And so we've got x log 5 plus 4 log 5 is equal to negative 9x log 9. We need to add 9x log 9 to each side, and then subtract 4 log 5 from each side. If we do that, we're going to be left with x log 5 plus 9x log 9 is equal to negative 4 log 5. Factoring out an x, we'll be left with x, then in parentheses, log 5 plus 9 log 9, and that's equal to negative 4 log 5. We just need to divide the right side and the left side by log 5 plus 9 log 9, and then we'll solve for x. So x will be negative 4 log 5 all over log 5 plus 9 log 9. Now there are some other things that you can do here. You could combine the bottom logs together, and that would be fine. But there really would be nothing else that you could do after you did combine those. So for now, this is fine. This is an exact answer. And then to get our approximate answer, we can just type this in to a calculator, and we'll see what we get. I don't think it's necessary to use parentheses here in this case, but I always like to just go ahead and put parentheses around the numerator when you're dealing with a horizontal fraction bar like this, just to be sure. And then we need a division symbol, and then we definitely need parentheses down here in the denominator. So that'll be log of 5 plus 9 log 9, and then we'll close those parentheses up. If we want to round to the nearest hundredth, this would just be negative 0.30. So again, our exact value and then our approximate value. To work with the right side, we're going to need to do something that's very similar. And if we do that, we can just take the logarithm of each side, and we can pull those exponents out to the front. So we'll have 2x minus 2. Remember to use parentheses when there's more than two terms, or more than one term rather. When there's two or more in here, in the exponent position, use your parentheses. Then we've got log 3, and this exponent will come out to the front, x log 2. Using the distributive property, we've got 2x log 3 minus 2 log 3 is equal to x log 2. Now we need to get this term with an x in it close to this one, so we could subtract from each side. That'll leave us with 2x log 3 minus x log 2, and then we need to add 2 log 3 to each side. Factoring out an x, we've got 2 log 3 on the inside of the parentheses minus log 2. That's equal to 2 log 3. Then we'll divide by 2 log 3 minus log 2 on each side, and we'll get x to be 2 log 3 over 2 log 3 minus log 2. Here's our exact answer. Again, we could play with this a little bit. We could take this 2, raise the 3 to the second power here. That'd be 9. And then we're subtracting logs, so we could make this log of 9 divided by 2. However, this is fine. To figure out our approximate answer, we can go ahead and just do 2 log 3 divided by 2 log 3 minus log 2. Make sure that you have parentheses around this entire denominator. And if you do, you should get about 1.46. That's an approximate value.